to pick up where we last left off, we are going to look at the hydrogen carriers, which helps us to reduce. So you have the lower energy ones, which is the FDA, the NAD, the NADP. They're all going to be reduced to carry the extra hydrogens. You know that happens when you're reducing alkanes to alkenes, and then alkenes, well, alcohol to aldehyde. So if you want alcohol, you better have two H's to get rid of. So, for carbohydrate metabolism, the ones that are catabolism, breaking down of molecules from food, you get the glycolysis, the pyruvate dehydrogenase complex, you get the Krebs cycle, and you get the respiratory chains. And also catabolism, the HMS, the pentose shunt, is also a form. It produces the NADPHs to supply the fatty acid and the nucleic acid synthesis. If you want anabolic reactions, ones that build up the molecules, then you get the gluconeogenesis and of course the glucogenesis, and also the polysaccharide synthesis. So remember the genesis, building up things. So, to review our energies again, from glycolysis, from a 1 glucose molecule, you get the 6 ADPs from the 2 NADHs. Remember, 1 NADH equals 3 ATPs, and 1 FADH equals 2 ATPs. So, originally this one had 2 NADHs and 4 ATPs, but we just used 2 of them to phosphorylate glucose, so we get 8. That's glycolysis. For PDC, pyruvate dehydrogenase complex, you get 2 NADHs, which translates to 6, of course, 6 ATPs. And for the last one, the TCA, the Krebs cycle, you get the 6 NADHs, the 2 FADHs, and the 2 GTPs. So is that equal? 6 NADHs is 12, 2 FADHs is 4, and the 2 GTP, because 1 GTP equals 1 ATP, so 2 GTPs equals 2 ATPs. So you get 24. So you get 8 plus 6 plus 24, you get 38. Yay! Okay. Get into the malate shuttle. You don't know what that is, but okay. So you have to know, in glycolysis, if you do it anaerobically, you only get 2 ATPs because the 2 NADHs totally does not count in anabolic anaerobic. But in an aerobic situation, you get the 8 ATPs because, you know, you only use 2 ATPs and the 2 NADHs still count. Yay. So, for glycolysis, you also have to know that the other monosaccharides, the fructose and the galactose, can also enter this pathway. And the enzymes for glycolysis are found in the cytoplasm of the cell. And the NADH and the NADH plus H can be used interchangeably. And not all the reactions are reversible. Some of them you need enzymes. So, to sum up, the anabolic, you get the glycogenesis and the gluconeogenesis. So glycogenesis, you're just turning the glucose 6-phosphate into glycogen. The opposite pathway for that is glycogenolysis. And then turning glucose 6-PO4 into pyruvate is, of course, glycolysis. And turning pyruvate back into glucose 6-phosphate is gluconeogenesis. Yay. So, yeah. I will do a summary of carbohydrate metabolism later.